Hello friends, let's have a look at problem 1582, special positions in a binary matrix. In this video, we're going to explain a function called zip. So here the question is that, given a matrix called mat, so we want to find the number of special positions in mat. So here a position ig is called special if the corresponding element in that position is 1, and all the other elements in the corresponding row and the corresponding column are 0, right? So we want to count the number of such special positions. So here, if you look at example 1, so you get this one, right? And for the second example, it's the identical matrix. If you review it as a matrix, then you get 3, right? So here, the length, the number of rows and number of columns are both bounded by 100, and matrix is a binary matrix. So here, let me do the coding directly, and we want to explain the point. So the strategy or the practice I would see here, practice is to use the zip function, right? So the zip function will combine two iterable. For example, if you have say a list, so say A equals say 1, 2, 3, and B equals say 2, let's see, just 2, 2. If they're not equal, they are going to result in a length which is equal to the smaller one. This actually result in a iterable, right? So if you zip this A and B, you are going to get tuples of 1, 2. So this is the first one and the element in, and the second first element from this B, right? So we also get 2 from A and 2 from B, right? And then actually, if you look at this, so say 1, 2, and 3, 4, right? And then you pass this to zip if you're using star. So let's call this maybe AX, right? So if we do this, mathematically it corresponds to do a transpose of this matrix. So you are going to get 1, 3, and 1, 3, and 2, 4, right? So this is basically what we are going to use. The reason is that checking for each position ig, so the element is rather simple, but we want to know the corresponding ith row. So this is also very easy, right? We just need to retrieve the ith row, but the jth column, so we need to use the transposed matrix. So in other words, we use the function to get the transpose of the matrix mat. So now let's look at the coding. So here first, I'm going to get mat transpose. It's going to be zip. So let's pass this one. And then we're going to use list to make it a list of tuples. And then what we are going to do, let's use a count variable. And then let me also get m and n as a number of rows and number of columns. So this is actually just for some convenience. And then we are going to iterate, say for I in range m, and for j in range n, right? So then we want to check if the matrix at this position is not 1. So we're going to continue, right? If it is 1, so we need to check if the corresponding row and the corresponding column has a sum that is 1. This is the very convenient. So if match the sum match, so the ith row. So now if we compute the jth row of the transpose, so let's see, transpose the jth row, it will correspond to the jth column of the original matrix. So if their sum is 1, it means that this position is special. Then we're going to increment the count by 1. So for maybe it's better to let's see, we can write the count here, right? Let's see, all this. So now we can do the return, right? Return the count. So this is a the way we are going to use to solve this specific problem. So now let's look at the code. Yeah, it passes one example. Now let's look at the generic case. Yeah, it passes all the cases. So I guess here we provided one way of solving this problem. So we take advantage of this zip function, and actually this function is very useful. So you can sort of modify the code or think of other ways to solve this problem. This one is the easy one. With that said, I guess that's it for this video. Thank you.